All right, so this last lesson is still on multiplication, but this time we're talking about specific products, and they will end up having specific patterns. So one thing I just want to remind you of, 2x minus 3, I'm just giving, you don't need to write this down, I'm just showing you another example. And let's do x plus 5. Remember that when we're multiplying today, the first term in the first parenthesis distributes twice, and then we also have the second term in the second parenthesis that's going to distribute twice. Now, sometimes people say, oh man, but that's a lot to keep up with, or sometimes you forget to multiply something. So I want to show you one option today. You won't always use this, but one option is to set this up like a multiplication table. And sometimes it just helps you not to forget pieces. So what we can do is take this first term and write it on, we'll say the top. That part doesn't really matter. So I'm going to split it apart and write it as 2x and minus 3. And then I'm going to split the second term apart, x plus 5. And now we can treat this like a multiplication table and just multiply the parts that go together. So notice in this first box, that's 2x times x, which is 2x squared. In my next box, I've got x times negative 3, which is negative 3x. All right, and then 2x times 5 gives me 10x in the bottom left, and then 5 times negative 3 gives me negative 15 in the bottom right. And then the only thing you have left to do is see if any terms combine, which is actually going to be the case right here. So my final answer will be 2x squared plus 7x minus 15. Now, you would have gotten this exact same answer if you had done this with the distributive method like we did in class today, what I have mapped out here at the top. But if you're having trouble keeping all that stuff straight, this kind of box method maybe just looks a little bit neater. All right, so let's dig into some of our examples for today. All right, so our first problem is going to look like this. It's called perfect squares because this is actually a multiplication problem. The squared tells me that the parentheses, everything that's in this parentheses, is happening twice. So the first thing I have to do is just rewrite the problem, 4x minus 5 times 4x minus 5. All right, that's what that means, that all of that is to the second power. And now I'm just multiplying like I normally would. The reason they call these squares is, one, because that's to the second power, but also if you think about doing the box method that I just showed you, when you write this out, you're going to have the same lengths on each side or the same values, which is what makes a square, is that each side is the same. All right, so I'm not going to use this method to work anything out unless you all just really want me to in class tomorrow. But if I go ahead and distribute, so 4x multiplies first, that should give me, let's see, 16x squared minus 20x. All right, now I'm going to distribute my negative 5. So negative 20x plus 25. And then notice the only thing that we have left to combine is this part in the middle. And so my final answer is going to be 16x squared minus 40x plus 25. All right, we'll do a few more together in class tomorrow and see if we can figure out why they call these a special product, see if we can find a shortcut. Okay, this next one is the most important. We're going to use this in all sorts of ways going forward, so you really want to make sure you see what's special about these. These problems are called multiplying conjugates, and the easiest way for me to give you a definition of a conjugate is just to show you some examples. So one conjugate problem could be 2x minus 3 and 2x plus 3, all right? Or we could have, let's see, 5x plus 1 and 5x minus 1, all right? Or we could have 6x plus 2y and 6x minus 2y. All right, so I don't know if you're noticing any patterns here, but you should realize that both of these terms or binomials are very similar, with the exception of the fact that one's negative and one's positive. All right, so the first term in each is exactly the same, and the second term is the same except for that they're opposite signs. Now, something that is not a conjugate, right, I can't do like, sometimes people think 2x minus 3 and 3x plus 2. So notice those have the same numbers, but the x values are different in each of them, and then these constants are different. So they have to be exactly the same with the exception of the plus and minus. So this is not an example of a conjugate. All right, so let's look at what it looks like when we multiply one of these out. So I'm just going to make a problem up for us. Let's do 3x minus 5 and 3x plus 5. Okay, so when we multiply, again, we're just going to do distributive properties. So I'm going to multiply my 3x. It's going to give me 9x squared plus 15x. Then I'm going to multiply my 5, or negative 5 rather, which will give me negative 15x minus 25. And when we do this, notice we're going to go combine like terms. That's right here in the middle. 15x and negative 15x cancel. And so my final answer here is going to be 9x squared minus 25. All right, I'm going to do one more, and then we're going to see if we can try to figure out the pattern that's happening. All right, so my next problem, let's do 2x plus 1 and 2x minus 1. Okay, so if I distribute again, that gives me 4x squared minus 2x. Multiply this 1, that's going to give me plus 2x minus 1. And now, final answer, I can combine these in the middle, which are going to end up canceling each other out, and I'm left with 4x squared minus 1. Now, when you do that, I think you should notice a similarity. So with both of those, they were conjugates. And with both of those, you hopefully notice that these middle terms cancel out each time. So the last thing I want you to do is kind of challenge yourself, and we'll talk about this tomorrow. I want you to try to see if you can figure out, if you just know the problem, can you think of a way that we could skip to the final answer? Is there a shortcut without having to work out all the multiplication? Now, I still want you to work it out in general, but the goal is going to be to find a shortcut from the problem itself to the final answer. And that's all for today.